Hello everyone. So today in this video we are going to discuss about projectile motion. So one of the important topic for Neet, JE, every time we get a question from projectile motion. Okay. So let us start and let us see what are the important points. So this video we will keep in two parts. In the first part of projectile motion in the today's video, so we'll be discussing about all the basics of projectile motion, and also we will discuss what are the different parameters in projectile motion that we are going to discuss, like the maximum height, range, and time of flight. What are these terms, and what are the relations, and what are the mathematical formulas are there, what are the interrelations. And in the part 2 video, we'll discuss in more detail in the advanced level of projectile motion. So we can say that the part 1 video we can discuss up to Neet level, and in the second part we'll discuss up to mains and advanced level. Okay, so pay attention to the first video here so that your basics will be clear, and you can also approach to advanced level questions and concepts once we go to the second part of the video. Okay, so generally projectile motion, when we discuss about projectile motion, what do you mean by projectile motion is, suppose we are throwing something in air and it moves under the gravity, under the influence of gravity, that is projectile motion. Okay, so the angle of throwing into air can be different. It can be starting from along the horizontal, we may throw to the along the vertical, means from 0 degree to 90 degree, whatever angle we will get. So we can throw a ball or any object in air under the motion of gravity, is what we call the projectile motion. And one more point I would like to add here, that projectile motion is not only restricted to gravity or that objects which are moving under gravity. So we can have projectile motion in some other cases, like suppose a charged particle is there and it is thrown into a region of electric field. There, if the charged particle's velocity is making some certain angles with the electric field, there also projectile motion can be created. Okay, so only for the initial point of view, only from the mechanics point of view, means we will discuss about the projectile motion under gravity. Okay, so when we discuss about the electrostatic chapter, there you will find that we will be discussing about projectile motion in more detail, uh, in that how the charged particle moves in an electric field. That concept we will discuss there. Okay, now what are the important points in projectile motion, important terms, and in point of view of mechanics we will be discussing. Okay, so here few examples we can discuss, like suppose a football is there and we are kicking the football into air, or a cricketer hitting a ball with the bat. The ball goes to certain height. Okay. Similarly, throwing a javelin. Okay. Similarly, these all comes under the examples of projectile motion. Clear? So first, before going into more detail, let us discuss what are the important terms that are going to be useful in projectile motion. So important terms, like we can say that here the diagram you can see, here I have taken a ball, and this ball is given an initial velocity, let us consider is u, and it is thrown with an angle of theta with the ground. So this projectile now, it will travel in air, and it will travel certain distance. After traveling certain time, it comes to again the ground. So let us consider this is point A and this is point B. So the distance between these 2 points, the horizontal distance between these 2 points is what we call the range. That means the distance between the initial point and final point is called range. Okay. Here, whatever more precisely we can say it is the horizontal displacement. Okay, the horizontal displacement it travels is what we call range here. Similarly, you can see that at this point the projectile will be at maximum height. Okay, let us consider this to be my point C, and the height covered here, this height we will term it as H max, maximum height. So these all parameters we are going to find out also mathematical formulas there, what formulas are there and what are their interrelations. These are also we are going to discuss. Similarly, whatever time it takes to completely travel from the point A to B is what we call the time of flight, which is denoted by the symbol of capital T. Okay, these three are important parameters, and here you can see the angle theta here is the angle of projection with which we have projected the projectile with respect to horizontal. Okay, so these are the different terms we are going to discuss throughout the chapter with more variations and more difference in height, difference in the range. Everything will be changing in each type of questions. So now let us start the brief discussion how the values are going to change and which value is going to remain constant. Clear? Okay. So let us consider this example only which I have given here. That here I have thrown a ball with an initial speed of u. You can see initial speed is u meter per second. So the ball makes an angle theta with the horizontal. That means here I can say the ball will now have a two components. So here I divide the velocity of the ball into two components. One is horizontal component which is given by u cos theta, and the other one is a vertical component given by u sin theta. These are the two components here we can see. So as the time passes, what happens to each of the components? So as the time passes, this u cos theta, it remains as u cos theta only. It does not change. It remains u cos theta at every point you see the ball or you see the object. Whatever be the point, the horizontal velocity remains constant u cos theta till it reaches the final position. Here also it remains as u cos theta only. Okay, without showing any variation in its magnitude or in its direction. The horizontal component remains same u cos theta only. Whereas vertical component, you'll see that the vertical component will keep on decreasing, and at maximum height the vertical component completely vanishes to zero, and after maximum height it again starts increasing, and at the end of the projectile it again becomes u sin theta with whatever speed you have thrown, same magnitude but opposite in direction. So here you can clearly see that initial velocity is u sin theta in upward direction, that is the vertical component, and here the vertical component magnitude is also u sin theta, but here it is in downward direction. Clear? So this is how the velocity shows the variation. So here let us consider this as a point D. Now I will explain you why this happens, why the u cos theta does not change, u cos theta remains constant, and u sin theta decreases and after some time it increases. So here one thing we can say that the gravity, the force, the acceleration due to gravity, which we consider, the gravity is always acting in downward direction. This all you know, gravity is always acting towards the surface of Earth. So, since the gravity is acting vertically downward direction, along this direction, the acceleration due to gravity, acceleration equals to g is acting. So as a result, here you can see that this u sin theta component is initially along vertically upward direction. U sin theta component is initially vertically upward direction, but acceleration due to gravity is acting downward direction. So now I can say that acceleration along the vertical is simply opposite to the velocity, initial velocity. I can say initial velocity along the vertical. Okay, so that's why the u sin theta value, it keeps on decreasing. Here I can write down that u sin theta, it will keep on decreasing and it becomes zero. It becomes zero at maximum height. After that it starts increasing, because after maximum height the vertical velocity component changes its direction. So here you can see vertical velocity component is acting in downward direction, increases, and again it becomes u sin theta at the end. So initially u sin theta was acting in upward direction. Now u sin theta is acting in vertically downward direction. Okay, here I can draw the arrow mark in downward direction. So u sin theta is acting in downward direction. Clear? So this is how u sin theta changes its direction. But whereas u cos theta, since it is acting in horizontal direction and acceleration due to gravity is acting in downward direction, so this velocity is not affected by the vertical gravitational acceleration, since the u cos theta is acting in horizontal direction. Clear? And there is no such acceleration here in horizontal direction. That's why u cos theta will not change in its direction. Clear? This is how we can say that the velocity in a projectile, it shows variation. Okay, so here again you see this diagram. Here I have marked a point, that is the D point I have marked. So you focus on this D point. Here on this D point, what would be the velocity here? Perpendicular velocity. We have discussed here that the velocity will decrease. But now my question is, how much will be the velocity? So you can simply use the formula here, equation of motion formula, V equals to U plus AT. So if I use that, so initial velocity along perpendicular direction is U sin theta. U sin theta minus GT will be the, what means, present velocity, or we can say this is the instantaneous velocity along the perpendicular. Okay, so that means here we'll write down few important conclusions that we see. Suppose here if I consider the initial velocity of a projectile is, let us consider the initial velocity is u. We have thrown it with the initial speed of u. Then this u velocity, when you split into different components and you write down in terms of I cap, j cap, you can write it down like u cos theta I cap plus u sin theta j cap. This is the initial velocity of projectile. So what would be the final velocity with which it will strike? So final velocity you can say u cos theta I cap, because this horizontal component is not going to change, it is going to remain constant, and here it becomes u sin theta minus u sin theta j cap. because here the vertical component changes its direction, so it is u sine theta j cap. Okay, so this is how the velocity shows its variation. Similarly, at any instant, if you wish to find out velocity, so we can say at any instant what would be the velocity is there. So we can say at any instant we'll having the velocity of velocity along the x direction, that is ux, or you can simply write down vx. So it would be u cos theta I cap. This will never change throughout the projectile, it remains constant. And similarly velocity along y-axis at any instant would be u sin theta minus gt, u sin theta minus gt into j cap. Okay, so in general, if you wish to write down the velocity at any instant, you can write it like u cos theta I cap, u cos theta I cap plus u sin theta minus gt, u sin theta minus gt j cap. Okay, u cos theta I cap minus u sin theta gt j cap. Clear? This is what we can say about the means instantaneous velocity equation at any instant. This would be the velocity equation. U cos theta I cap is initial velocity plus u sin theta minus gt j cap. Clear? Okay. So at any instant also, if you wish to find out the angle, whatever angle it makes with the horizontal, like here you can see that initially suppose I am throwing a projectile with some angle. Here angle is theta, with angle theta I have thrown, but as the projectile propagates along its path, suppose now at this instant, this is the ball, now velocity, instantaneous velocity would be along this direction. So if I draw a horizontal line here, then here I'll get some other angle which is not equal to theta. So this angle is called here alpha angle, I can say. So how can I find out this alpha angle? You see, so at this present movement now, I'll have two components of velocity. These are the two components of velocity. So one is, as you know, u cos theta remains same, u cos theta, and vertical will be u sin theta minus gt. This would be the vertical velocity. So here you can use simple trigonometry form, and you can find your alpha as, alpha will be how much here? Tan inverse of u sin theta gt, u sin theta minus gt by u cos theta. So this will be the value of angle, any instantaneous angle we can say. This is the value of instantaneous angle made by the object at any instant, we can say, with respect to horizontal. Clear? Okay. Now let us discuss the three important parameters. Like here we're discussing about range, maximum height, these all things we'll discuss. So here I have considered the ground, and let us consider the ball. Suppose this ball is now thrown with an initial speed of u velocity. It is thrown at an angle theta, and it covers the path somewhat like this. It covers a path and reaches here. Okay. So during its path, what will be the projectile? What are the different terms associated? I already told you about this. So let us consider here. This is your initial velocity along vertical, u sin theta. You all know. Just right now only we discussed, and along this we have u cos theta. Okay, so let us consider this point as A, this is your point B, and similarly the maximum height point here. Let us consider this point as a C point. Okay, this is your H max point C. So when we consider our journey from A to C, so here we can consider our journey from A to C, and let us only consider only vertical, only the vertical motion only. Here we can consider only the vertical motion. Let us consider this. Okay, only vertical motion. Let's see about only vertical motion. What happens in vertical motion? So here I can say that initial velocity along vertical is u sine theta. Final velocity here along the vertical will be 0 because here I am considering my initial point as A, final point as C, and acceleration along vertical would be minus g because since it is acting in the opposite direction of u sine theta. So now here we can simply use the formula of simple equation of motion v equals to u plus at, or you can simply write down along the y direction, these all parameters you have to write down. So velocity along, now velocity along vertical, if you write down final velocity, we have written here a final velocity 0, initial velocity u sine theta minus g into t, so which gives me the time is u sine theta upon g. This is the time of flight I got, but listen here, this is only from A to C. Here I got this from A to C, means from that point of projection to maximum height. If I wish to find out the total time required, so I can write down here total time of flight. Total time of flight will be how much? See, total time of flight will be simply the twice of the time required to travel from A to C. That equals to, we can say that capital T equals to 2 u sine theta, 2 u sine theta by g. Okay, this is the final formula we are getting for total time of flight. Here t equals to 2 u sine theta by g, or further you can also write it like 2 into u sine theta is your initial velocity along y direction divided by your g is acceleration along y direction. This form is also important. You can also mention this in this form also, time of flight. Okay, now same way let us consider for maximum height. Again we are considering our motion between A and C. So here maximum height we are going to calculate H max. So when you are going to find your H max, again we are considering motion between A and C. So in this case we are going to use the equation of v square minus u square equals to 2as, 2 into acceleration into displacement. Okay. Now you see I'll take displacement along vertical direction from A to C. So along vertical direction, again the final velocity becomes 0 minus initial velocity u sine theta whole square equals to 2 into acceleration along vertical direction is how much we are having, acceleration minus g, and displacement we are having is h max, because along vertical direction displacement is h max. So we are getting here h max equals to u square sine square theta by u square sine square theta by 2 into g. This is our h max formula. H max equals to u square sine square theta by 2g. Clear? So this is how we can say this is the h max. H max equals to u square sine square theta by 2g. Very simple form. And this also you can write it like u sine theta whole square. So u sine theta is u y uy whole square divided by here the simple division divided by 2 into acceleration along y-axis. This form also you can write down. Okay. So this is the formula for maximum height record. And the last form we're going to discuss is about range. So the third one is range. Range. So all of you see what is range. Range, we can say that range is simply the horizontal displacement which is taking place. The range is nothing but the horizontal displacement. That is in the previous diagram which we are discussing between A and B. That is what we call range. So for range, actually, how we can find out this range? You can say that range is a kind of horizontal distance or horizontal displacement. So horizontal displacement is horizontal velocity into the time required to go from A to B. So horizontal velocity we are having u cos theta is your horizontal velocity into time required already calculated to u sin theta by g. Okay. So when you solve this one, you get 2 into u square sin theta into cos theta by g. And further on simplifying this, you can write down range equals to u square sin 2 theta upon g. Range equals to u square sin 2 theta upon g. Here, this is what we call range. This is the formula for range. Here, or this can also be written in the form as range equals to 2 into one of the you multiply with sin theta, so it becomes u sin theta. We can say u sin theta and u cos theta, so ux into uy by